Today we're going to learn how to find missing side lengths using the Pythagorean theorem. You should be on page 26 in your notes packet. Before we get started, let's review our key vocabulary. The hypotenuse is the side that is opposite the right angle in a right triangle. That number is always the longest side of your right triangle. The legs of a triangle are the two sides that are adjacent to the right angle. In this right triangle, you can see that side length AB is adjacent to the right angle, and side length BC is also adjacent to the right angle. So those side lengths would be your legs. Side length AC is opposite or across from the right angle, so that would be your hypotenuse. In your first triangle, you want to figure out whether you are missing a leg or a hypotenuse. We see that this is our right angle, and so 6 would be considered a leg, so I'm going to label it A. 8 would be considered a leg as well because it is also adjacent to your right angle, so I'm going to label it B. I'm going to label my hypotenuse as C. Now we are missing the hypotenuse, so we're trying to find that side length. We remember that the Pythagorean theorem is a squared plus b squared equals c squared, or leg squared plus the other leg squared equals the hypotenuse squared. I'm going to just plug into my formula. So A is 6, so I'm going to say 6 squared, plus B is 8, so 8 squared, equals C, which is what I'm looking for, so C squared. Well, 6 squared means 6 times 6, which is 36. 8 squared means 8 times 8, which is 64, and all of this equals C squared. 36 plus 64 is 100, so now I have 100 equals C squared. Now, my goal is to get C by itself, but right now C has an exponent with it. So since it's an exponent of 2, I can get C by itself by doing the inverse, which is taking the square root of both sides. The square root of 100 is 10, and the square root of C squared is C. So that means that my missing side length here is 10. For our next triangle, we can see that we're missing a leg. So we have one leg here, that's side AC, which has a measurement of 20. Side BC is going to be our other leg, and our hypotenuse is right here on side AB, which is 25. So when I plug this into my formula, I'm going to say 20 squared plus B squared, since that's what I'm missing, equals 25 squared. Well, 20 squared equals 400. 25 squared equals 625. Now the goal of an equation is to get our variable on one side by itself. Well, right now, obviously our variable has this exponent of 2, but it also has 400 with it. So the first thing that I want to do is get rid of my 400 by doing the inverse, which is subtracting 400 from both sides. My 400s would cancel to leave me with b squared equals, and then 625 minus 400 is 225. Now b is almost by itself, but to get b by itself, I'm going to have to take the square root of both sides. So the square root of b squared is b, and then the square root of 225 is 15. So that means that my missing side length measures 15 units. My next triangle looks like it's missing a leg. So we have a leg here of 5, but we're missing this leg, and even though it's labeled x, I'm going to call it b so I can put it in my formula, a squared plus b squared equals c squared. And then our hypotenuse is 7. So when I plug this into my formula, I'm going to say 5 squared plus b squared equals 7 squared. 5 squared is 25, and then I have 25 plus b squared equals 7 squared, which is 49. Now again, I need to get b by itself, so I need to get rid of my 25 first. So I am going to subtract 25 from both sides of my equation. My 25s will cancel to leave me with b squared equals And then 49 minus 25 gives me 24. Well, now I need to take the square root of both sides. The square root of b squared is b, and then I have the square root of 24. Well, 24 is not a perfect square, so I would not get a perfect whole number for this. What I can do is simplify this, and you have different options here. If you have to give a perfectly precise answer, then you would want to just simplify your square root. Well, the perfect square that will go into 24 is 4, so I can split it up into the square root of 4 times the square root of 6. Well, the square root of 4 is 2, so this would be 2 times the square root of 6. If your answer is allowed to be rounded, then you can put it into a calculator and you can round it to the nearest tenths place. If we put the square root of 24 into a calculator, we're going to get approximately 4.9 when we round to the nearest tenths place. So we can say that this answer is either 2 times the square root of 6 or approximately 4.9. For our next triangle, we can see that we're missing a hypotenuse. So we have 24 and 18 as our legs, and we're missing C, our hypotenuse. When we plug into our formula, we're going to say 24 to the second power plus 18 to the second power equals C to the second power. Well, 24 squared equals 576, and 18 squared equals 324. And all of this equals C squared. When I add 576 plus 324, I get 900, so I have 900 equals C squared. Well, again, we need to take the square root of both sides. The square root of 900 is 30, and the square root of C squared is C. So my answer is that 30 equals C, so the hypotenuse is 30. For my next triangle, I see that I have legs that are 53 and 43, so I'll label those as A and B. And what I'm missing is my hypotenuse C. So I'm plugging this into my A squared plus B squared equals C squared formula. 53 squared equals 2,809. 43 squared equals 1,849. Well, then I need to add those together. When I add both of those together, I get 4,658. So I have 4,658 equals C squared. So I'm going to take the square root of both sides. And when I take the square root of 4,658, I'll notice that it's not a perfect square. So I'm going to put this in simplest form. 4,658 is actually not a number that has any perfect squares that will go into it. So we would just leave it as the square root of 4,658. Or we can put it into our calculator and round it to the nearest tenths place. If we rounded it to the nearest tenths place, we would get approximately 68.2. So our hypotenuse can be written as either the square root of 4,658 or approximately 68.2. For our last triangle, we see that we have a leg of 9, and then we're missing another leg, and we have a hypotenuse of 14. So when we plug this into our formula, we have 9 squared plus b squared equals 14 squared. Well, 9 squared equals 81, so we have 81 plus b squared equals, and then 14 squared equals 196. Well, we know we need to get b by itself, so we first need to get rid of 81. So we will subtract 81 from both sides of our equation. Our 81s will cancel to leave us with b squared equals, and 196 minus 81 gives us 115. Then we would take the square root of both sides, which would leave us with b equals. And again, 115 is not a perfect square, and it also does not have any perfect squares that will go into it. So our solution is just the square root of 115. We can also find the approximate value of this by rounding to the nearest tenths place. And if we do that for this number, we're going to get approximately 10.7. So for this, we can say the square root of 115, which is the precise answer, or we can say that that is approximately equal to 10.7.